Welcome back, Chill Pills, to Quiz Time Solutions number 16. An IV order calls for the addition of 45 milliequivalents of calcium carbonate. You have a 25 milliliter vial of calcium carbonate, 4.4 milliequivalent per ml. That is your concentration. How many milliliters of this concentrate do you need to add to this IV compounded sterile product? Starting with our given information, the dose ordered is 45 milliequivalents. That is the total concentration that we need. The total dose ordered will then equal 45 milliequivalent per an unknown volume that we are to draw out of our 25 milliliter vial and then add into a separate IV compounded sterile product bag. Our dose on hand is a 25 milliliter vial that has a concentration of 4.4 milliequivalent, but we're trying to get to 45 milliequivalent. So how do we get there? Once again, we're going to utilize a ratio proportion to solve for this equation. And I know you all may be tired of ratio proportion at this time, and I will introduce two other formulas for us to utilize in coming videos, so please be patient. But thankfully, this question is easy enough that we can utilize a ratio proportion equation. And the more you do it, the more you get comfortable, the more you can do it right offhand, and you don't have to struggle thinking, where do I start? So with our ratio proportion equation set up, we will set up our concentration of our dose on hand, 4.4 milliequivalent per 1 ml on the left-hand side, and our total dose ordered on the right-hand side, 45 milliequivalent per our unknown volume, X milliliters. We will then cross multiply, and we'll put our X on the left-hand side, 4.4 milliequivalent times our unknown volume of milliliters. Set that equal to 45 milliequivalent times 1 ml would then give us 45 milliequivalent per ml. Then we divide both sides of the equation by 4.4 milliequivalent. 45 milliequivalent divided by 4.4 milliequivalent will yield 10.22 milliliters. Now let's solve or answer our question, our quiz question. So how many milliliters do we need to draw out of our 25 milliliter vial? Is it 8.4 milliliters, 10.2, because generally you will round up to the nearest 10th, 12.8, or 5.6? And the correct answer is 10.2. Oh, I'm always so messy when I draw. Should I try it again? The correct answer is 10.2. All right, there you have it, Chill Pills. I hope that was simple. I do want to point out, Chill Pills, when you're faced with a complicated word problem that looks complicated, you want to identify your values, your given information, and things that you know that you can easily solve and plug into a equation. What we can do with this quiz question is identify the concentration 4.4 milliequivalent per ml. There is a simple formula that you can utilize. A second way to solve for this equation without utilizing a ratio proportion equation is to set up the dose ordered divided by dose on hand equation only when you have a concentration that's in unit per 1 ml. So if you ever are faced with a concentration that has units per 1 ml, you can utilize the formula dose ordered divided by dose on hand. So let's try it. So our dose ordered is 45 milliequivalent divided by dose on hand, 4.4 milliequivalent. Very similar to what we've just done with ratio proportion, only with ratio proportion, we mapped out each step that would lead us to this final answer. But The dose order versus over dose on hand is a quicker way to get to the answer. Is the best way to get to the answer quicker without wasting time mapping it out and seeing where the numbers go. I like to do that just so you can see how the math is mathing. But as we progress, you should be able to calculate these questions a lot quicker utilizing the best formula for each question. So for this question, the best way to solve for it is actually to utilize the dose ordered over the dose on hand. I think it's called the basic formula as well. If you were to study it separately, you would research basic formula exam questions. So 45 divided by 4.4 milliequivalent, but that's not the full dose ordered. Actually, it's not the full dose on hand equation. It's actually 4.4 milliequivalent per 1 ml. You would then multiply by 1 milliliter, which is the concentration of the dose on hand. So long as your dose on hand is in unit per 1 milliliter, you can easily utilize the basic formula. Dose ordered divided by dose on hand times 1 milliliter will simply lead you to the same answer, equals 10.2 milliliters. So it's not necessarily that you are multiplying by that 1 ml versus it's understood. You just do simple division. Dose ordered divided by dose on hand. Multiplied by the 1 ml is just understood, and you don't actually have to write it out. You just understand it. You get a quicker answer, 10.2. You don't worry about everything else. You just understand, multiplied by that 1 ml, the math is mathing. And you can see your answer quickly through your multiple choice. I hope that makes sense. If you have any questions, please drop a comment down below and make sure to like and subscribe if you like the resolution to this question. See you next time, everybody.